1, we're going to call it lesson 10. Okay, so this is unit 1, lesson 10. So integral exponents essentially means we're talking about integers, so we're talking about negative exponents and what happens to negative exponents, okay? There's some kind of, I don't want to say tricks, but just different ways to view them. But anyway, so let's kind of go through this chart here. They kind of use the base 10 here to kind of give you an idea of what's happening. So as you kind of go through, you see that you have 1,000's 10 cubed, 100's 10 squared, yep, and 10 is 10 to the 1. And then we know 10 to the 0 power is 1, right? We're aware of that? Yeah. Okay, hold on here. Yep. Okay, so now what happens is 10 to the negative 1, we see what's happening. Our exponents are getting smaller, and as they get smaller, we have less zeros, right? And so it's 1. So now what we're going to do now is the 0, the decimal jumps to the other side. It's 1/10, or 0.01. Okay? All right. Well, so back to what we were saying here. So then again, what happens is now it jumps to the 0 jumps to the other side. So it's, sorry, it's not 0.1. I wrote that wrong. It's the decimal goes on the other side of 1, so it's 0.1. That's 1/10. 10 to the negative 2 is 1 over 100th. So that would be 0.01. Okay, or you can write it as 1 over 100. Okay, 10 to the negative 3 is 0.001, or 1 over 1,000. So another way of thinking about this is if you have a negative exponent, what that really means is it's on the denominator. What do I mean by that? These are on the top. Like these are, yeah, these are all over 1, right? Because they're whole numbers. But as we get negative exponents, they're now on the bottom. So that's what the negative exponent does. It pushes it down in the denominator. That's kind of just pretty much the quickest way I can explain negative integers. Negative integers are positive on the bottom. See how they have this is 1 over 10 to the 1, it's positive. This is 1 over 100, so that's 10 squared. So to write your integers, your exponents with integers as positives, you push them down. So just in that same respect, it'd just be like this. Just like that. They're positive on the bottom. So then that would just be, this one's 1/3. That's pretty much what it is. You can write 0.33 if you want. Okay, that's 1/9. That's 1/27. Okay, we know that a to the 0 is 1. We know that a to the negative 1 is 1 over a. That's just going to be 1 over a squared. It's pretty hard to do this. And then 1 over a cubed. You guys get the idea. The right side of the board is going to be trouble. Hopefully not lots on the right. Okay, so then it says write the following with positive exponents. This is what I'm talking about. So if I'm writing them with positive exponents, what that means is I'm putting them where? What did I just say? No. Bottom, yeah, on bottom, on the denominator. To make these have a positive exponent, you write them on the bottom, just like that, 1 over 10 to the 7th. Okay? All right, and then this one here, 1 over 3 to the 5th. And this one here would be 1 over a to the negative, or to the n, sorry, not negative. Okay. So now what happens is when we're talking about these, we're talking about when we're doing some of our exponent laws from the last 2 lessons, now we're going to have stuff where we end up with stuff left on the bottom. So 5 to the 4th divided by 5 to the 7th, that means you're going to have 5 cubed on the bottom now. So it's not going to cancel the top. So with that being said, we just know that we have 5, 5, 5, 5, 4, 5, 6, and one more. Okay? And so then we know that cancel, 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 cancel. We're left with this in the bottom, which can also be written as 5. Holy moly. Okay, it's going to be written as 5 to the negative 3 I'll let you guys write that. It could be 5 to the negative 3. So you have 4 minus 7, negative 3. Okay, any questions on that? So what if I did this? A little challenge question for you. Do you have a question? No? Okay. So what if I did this? What if I said you had 1 over 3 to the negative 4th? Yeah. You flip it again. So pretty much the game is, whenever you have a negative, you push it to the opposite numerator or denominator. This is negative on the bottom. To make it positive, I want it on the top then. Okay? If I had 3 to the negative 4th just regular, to make that positive, I'd push it down. So all I'm telling you is this one, it would just be 3 to the 4th. Wherever the negative is, you move to the opposite numerator or denominator to make it positive. Any questions on that? That's just pretty much, that's the overlaying rule for this. Okay, if you get that down, you'll be fine. Okay? All right. Okay, the results in A to C are examples of the general rule where the base is raised to a negative exponent. So we just know that a to the negative p is 1 over a to the p. Write the following with positive exponents and evaluate. So this would be 1 over 2 to the 1, which is just 1/2. Okay, that's 0.5. 1 over 3 squared, which is 1/9. 1 over 4 cubed, which is going to be, I'll write it over here, 1 over 64. Okay, no questions yet? All right. All right, negative exponent in the denominator. So I kind of jumped the gun already. Caleb already knew it was coming. So all that happens, see, it just 4 to negative 3, they just moved it to the top, made it positive. Okay? So again, I'll say it one more time. I know I'm being redundant. Wherever you have a negative exponent, you move it to the opposite, wherever in the fraction. So it doesn't matter. So if I have the fraction, if the negative's down here, I move it up here and make it positive. If the negative's up here, I move it down here, I make it positive. Just the opposite numerator denominator. Okay, so then here's the law. A to the negative n is 1 over a to the n. 1 over a to the negative n is just that now with a positive. So this is like the rule. If you want to highlight this is a rule here. See that? Ran. Woo. Okay, so that's the negative exponent law. Okay, like as you said, the pen's getting a little trouble today, so I'll just kind of do D and E probably down here, just so that we can write them better. All right, so this one here, 4 to the 5th times 4 to the negative 3. So this is just, we're just simplifying, and it does say evaluate without using calculator. So 5, we still go 5 plus negative 3, so we're still doing integers. Okay, good, so it's 4 squared, and that evaluated 16. All right, 4 squared, 16. Okay, this one here, 2 plus a negative 5. Negative 3, good. So I have 3, well, I can write this one over here. We have 3 to the negative 3, which is 1 over 3 cubed, which is 1 over 27. You can go ahead and write that decimal if you want. 1 over 27 works. So again, negative exponent, we pushed it down, and then we evaluated. Okay, this one here, it's 1 over 2 to the negative 5th, so that's simply 2 to the 5th. We pushed it up. Okay, this is a negative, so we move it to the opposite numerator denominator. 2 to the 5th is 32. Okay, and like I said, I'm going to do D over here. Okay, so D, negative 7 over a negative 5. They have the same base, so we can do the quotient rule. Okay, so it's negative 7 minus a negative 5. So minus a minus is positive, so it's going to be 6 to the negative 2. Negative 7 plus 5. Okay, what do we do now? Put it down. 1 over 6 squared, 1 over 36. Okay, then I'll do E here. I'll just erase B for now. So this is E. 2 cubed to the negative 1. Okay, 2 cubed to the negative 1. So we have, what do we do with this negative 1? What kind of rule is this for exponents? Power to power, right? So we multiply. Yeah? Yep. Power to power. So you multiply. 3 times negative 1 is negative 3. So I have 2 to the negative 3, so I write that as 1 over 8. Where'd the 8 come from? 2 cubed. 2 cubed is 8. Okay, again, that's E. Okay. Questions? This is completely new. You haven't seen negative exponents before. So this is no longer a review. Yeah, Rich?
So on number E, the negative 1, it affects the root and the number?
No, the negative 1 just hits the exponent.
Okay.
Is that your question?
Yeah.
Doesn't hit the 2 at all. Okay, good question. Anything else? You got a question, Maddie?
No.
Okay, still figuring it out. And if you're still in the figuring out stage, that's fine. We got more examples coming.
Okay, wait. No,
Yeah.
sure. So you times negative 1 is negative 3. So then wouldn't you do 1 over
2 cubed.
2 cubed and then 1 over 32?
Uh,
Or 1 over...
2 cubed is 8.
Oh, okay.
Yeah.
Or so wouldn't you do 1 over 8?
Yeah.
Oh, okay.
Oh, yeah. Gotcha. Okay. Anything else? Okay. All right. Identify the following as true or false. So do they do these correctly? Okay. 3 minus a negative 1, so that's plus 1. So good guess, Ollie. True?
No, I knew that.
You knew that one? Good. Okay. All right, well, Josie, what do you think about B? True or false?
False.
Why? It does, actually.
Oh.
But you are correct. Luke?
Because like the bases are the same.
Yeah, you can't divide, guys, if the bases are different. We can't do exponent work with different bases. The bases, that has to be 8 and 8 or 4 and a 4 like this. You cannot divide bases. A couple of you guys were doing that on the practice work yesterday. You were timesing the bases. You cannot touch the bases. The bases have to hold the same because, just a second, Ollie. If I do this and I call this 12 to the 4th, that's not right because what this is 3 times 3 and 4 times 4. Okay, 4 times 3 is 12. 4 times 3 is 12, but how many 12s are there? 2. So you've changed things. You can't do that. So if you ever give them this, that's as far as you can go. You can't mesh the bases together. Okay? So that's why this is incorrect. Ollie? Perfect. Okay? So this one, is it true, Logan? True, right? We can move that one down. So C is true. This one was false. And then D, we'll go back to Maddie. Okay, close. They tricked you because the a to the negative 3 is supposed to go to the bottom, but something went with it. The 9 shouldn't go with it. The 9 doesn't have a negative exponent, right? The negative 3 is only on the a. Top. Okay, so that's what's wrong with this one here. So I'll write D over here. So D's problem is the 9 just stays on top, so it should be this. 9,
A, right?
correct, 9 over A3. The 9 on top, Raj. Yeah. Okay. Yes?
So then if it was like, say, the 9 and the A were in brackets?
Then the whole thing would go on the bottom.
Okay.
Yep. You guys hear that? So if it was 9a bracket negative 3, then the whole thing would go on the bottom with a 3. Okay, good. All right, let's keep going here. Simplify and arrange and write with positive exponents. Okay, so we'll kind of come down here, Lauren. So what do you think about A here? So you're going to simplify it and then write it with positive exponents. So first step is what's negative 4 plus negative 3? Plus. Right? So A, negative 7. And how do I write A negative 7 with positives? That's it. Okay, good. Okay, B, Hannah? Yeah, it's tricking you. So does the 6 and the 2 have an exponent? So we can divide those. Okay? Do you guys understand the difference? 6 and 2 are not bases. What's the base of my exponents? X. So x has to be the same, which they are. So we can divide 6 divided by 2, which she's asking. Okay? So I'll give it to you here. So it's 3. 6 divided by 2. And then your x2 divided by your x7 is a x what? Next negative 5. And so then we'll write x negative 5. And then now how are we going to write it with positives? 3 over x5. The 3 stays on top because the negative is only on the x. That's where most of you are going to make your mistakes. The x is the only thing that has the permission, if you will, the negative exponent to move down. Okay, I'm going to do c right beside it here. So, Isla. Okay, yep, positive 11 or negative? Good, so y11, 2 just stays there, correct. y11 over 2. So what happened here is we had a 6 minus a negative 5. That's really 6 plus 5. So it is a positive exponent here. We don't have to move anything. That's where it's at. The 2 stays where it's at because the 2 doesn't have an exponent. Okay, good. Turn the corner, Denise. How about this one? Yep. Okay. So negative 2 brackets negative 3, x to negative 3. Just focus right now on the exponents. Make them positive before you actually take care of the 2, okay? So what are we going to do now? On the bottom. So they're all on the bottom with positive 3's now. Now we can do what negative 2 to the third is. Negative 2 times negative 2 is 4. Positive times another negative 2 is a negative 8. So this right here would be 1 over negative 8x cubed is the best way you can write D. Okay. E, Luke. Okay, 8 divided by 4 is 2. Okay, and we can't do anything with the a and the b's, but what will we do with them? Because they're both negative, so they'll switch spots, right? We want the b up top and the a on bottom. So we'll write 2b cubed over a to the fifth. So we did 8 divided by 4 is 2. The b came up, the a went down because they were negatives. Okay. And then I'll write f right under e here. So Ridge, what do you think for f?
You leave the 4 on the bottom.
Yep.
And the a,
So this one here?
Oh.
Yeah, sorry, we're on f.
Okay. Yeah, sorry.
Sorry.
It'd be, oh, okay, so you leave the, would you leave the 5 on top?
No, because it's in brackets. So the negative 2 hits the 5 and the p. So it's going to start out like this. It's going to start out as 5 negative 2, p negative 2, all over 5q4. And so what happens now? We need to move the stuff on top.
Yeah, so you have to move both of them down.
Right. And this is going to come down, so what it's going to be is it's going to be 5 squared times 5 q4 p squared. So if everything got moved down, what do we leave on top? A 1. Good. 5 squared is 25. So your best answer, and again, I'm sorry because my board, I'm writing kind of weird here, but it's going to be 1 over 125 q4 p2. 125 q4 p2. 25's here times 5. That's how I got 125. 5 cubed. There's 3 5's in the bottom. Okay. Okay, keep talking through here. Almost done. All right, so this one, simplify and write the answer with positive exponents. So I'll kind of take this one for you. So what we want to do first is I would simplify this first and then do the division. So if we simplify this first, we're going to have, this is going to be gone because there's 5 of these, but there's 8 of these, so these are now a 3 because 8 minus 5. 3 minus a negative 3 is plus 3, so this is now a 6. I did that one. Negative 1 minus 2, this one gets pushed down so that we have a z3 on the bottom. Okay, so what do you do when you're dividing fractions? What's the process for dividing fractions? Flip and multiply, right? So I need to flip the right one and multiply it to the left one. So 5x3 y. I'm actually going to go ahead and change these right now. These are negative, so I'm going to put them where? On the bottom. So I'm going to go 5x3 over y8 z2 multiplied by, the only thing that's going to be on top is the z3. And then this stuff's on the bottom now because we flipped it. Okay, so now we're just going to figure out what can we cancel here. So we'll start one thing at a time here. So let's go with the x's. I have an x3 on top and an x2 on bottom. So what happened? 3 minus 2 is what? 3 minus 2.
1.
Right, so this is gone. That's a 1 now. So we'll write this, we'll write right here. So we have an x1 on top. So we did the x's. z3 over z2. z1 again. Those are done. I have a bunch of y's in the bottom of a y8 and a y6. So I have a y14 on bottom. That's done. What is 5 over 15 reduced to? Close. 1/3. So you don't have to put the 1 on top, but the 3's on the bottom. So that would be your answer right there. xz over 3y14. xz over 3y14. Yep. 15. This guy? 2. Oh, yeah, it is 3. Good job. Thanks. So that means they went away, huh? X cubed. Sorry. Good job. Picked up my bad handwriting. So that just means the x is gone. So we don't have to change too much there. This was a 3, not a 2. That was the problem. Okay, good. So there is no x's. So z over 3y to the 14th. Okay. So then quickly explain this. I'll let you write this in your own words. But why is this wrong? Because a 2 does not have a negative exponent. So you need to write something along those lines in the explain. The 2 does not have the exponent on the p only does. So this should be a 2 on top, the p cube on the bottom. Okay, questions? All right. Okay. Simplifying a fractional base with negative exponents. So consider expression 2/3 to the negative 4th. So now we're talking about fractions is all. Okay. So what happens with fractions essentially is that if it's a negative fraction, we know, like, what's the rule for exponents with just, let's just slow down for a second. I'm sorry, I'm talking through myself. If it was just 2/3 to the 4th, what do we do with the 4? It hits both. So if it's a negative 4, is that going to change? So then really, you're going to hit both the negative 4 and then do what? Flip them. Does that make sense? And what I want you to think that about is it's the inverse. A negative actually is another word for an inverse. Okay? So when you flip a fraction, that's the inverse of it, right? 1/3's inverse is 3. 1/3 times 3 is 1. An inverse of itself is 1 when you multiply them. Okay, so this case, 2/3 flipped is 3/2. Okay, so that's what they're doing in this investigation here, showing you that, okay, so we know it's 2/3 of negative 4, so we push this down. Okay, and then we're going to end up hitting those with -4s and pushing them back up, and it looks like this. It's the same thing. So what you can tell yourself, oh, I see a negative, I'm going to flip my fraction and make it positive. You can do that. Okay, or you can flip them and hit them both with 4s right away, however you want to do it, but the idea is that they're the same. Okay, so classify the following statement. This is true. 2/3 of -4 is the same thing as flipping it and making it a positive exponent. So it suggests a quick method for evaluating 5/2 of the -3rd. So what would your method be? Probably to flip it and then hit it with 3s. That's what I explained there. I'd flip it to 2/5 and then hit it with a 3. And that's what this is telling you to do right here in the rules. That's a math rule, I guess you'd call it, whatever, for fraction and negative exponents. Okay, questions, concerns, comments, complaints? No? All right. Okay, so that's it for this one.